Welcome to the lesson on angle bisectors. In this lesson, we will investigate the properties of angle bisectors and how we can apply those properties to solve some basic problems. Now, as we can recall, an angle bisector is a ray that cuts an angle into two equal parts. Now, on that ray, we expand that every point is equidistant from the sides of that angle, and this allows us to then create a lot of shapes with a lot of very concrete properties. But let's say that I'm going to go ahead and create a very large angle here. If I were to make an angle bisector, and let's just say I'm illustrating this angle bisector just for the sake of doing so, not necessarily to be accurate, I'll go ahead and say that these two angles are congruent. I can pick any point on this gold ray, and the segments made from each side or to each side of those angles are going to be congruent, no matter how many I draw. I can continue on and make them larger, or I can come back down here and make them smaller. And because it's the shortest distance from that angle bisector, all the angles made by those new segments are indeed 90-degree angles. They're always going to be perpendicular. But let's go ahead and prove what we just drew, especially since I just drew it out in space without necessarily a construction. So with everything being said here, I know that B is a point on this angle bisector. So angle 1 and 2 are congruent. Angles F and E are both 90, and that AB, of course, is congruent to itself. Now I want to prove that FB and BE are congruent. Now, because I have two angles and a side not between those, these two triangles I've made are congruent because of angle, angle, side. And thus, all the corresponding parts of those triangles are indeed congruent, including what we're trying to prove, which is that FB is congruent to BE. But let's apply these principles with a practice problem. So in this figure, I need to find the measure of the angle BDC if I know that this large angle, ABC, is already 112 degrees. Now I know I have an angle bisector because of the two right angles and the fact that AB and BC are equal, but I'll instead try to use the fact that this figure overall is a kite. So ABC and ADC must be equal to 180, so if I subtract 180 from 112, I will get 68. And if ADC is 68, BDC, which should be half of it because the angle's been bisected, should end up being 34 degrees. Now I'm taking a look at another example. I have another angle bisector, again with the presence of the right angles, and the fact that DF and ED are both 7. And I know that this large angle EAF is 118, and I'm trying to find this smaller angle ADF. Now again, I can take that angle 118 and divide it by 2, which will give me the smaller angles DAF, which will be 59. Now again, I can use the smaller right angle triangle and take 180, subtract 90, subtract the 59 I just found, and then get the small angle that I'm looking for, ADF, and get its measure, which is ultimately 31 degrees. Now let's continue to do more practice problems so that we can apply a variety of all the principles that we've already investigated. In number 4, I know that ADF is 93. This whole angle with 3 smaller angles is 93, and I want to find ABD, so the angle all the way on the other side. So I can apply some principles of triangles to take 180, subtract 90 from that right angle, to subtract 69, and the small angle in here, ADE, is 21. Now I know that these two small angles, EDB and BDF, are both equal to 72 together, and because EDF has been bisected, I can take that total sum, 72, and divide it by 2 to get 36. So EDB ends up being 36. Now that gives me a third angle in the triangle that ABD is a part of. So I take 180, subtract 90, subtract 36, and I get 54. So the angle I'm looking for, ABD, ends up being 54 degrees. In this last example, I'm looking for the total measure of this large angle BAE, which I already know 2 of the parts of the angles. I'm also looking for the segment on the side, DE. Now, because this is also another angle bisector, because I know the sides are the same, BAC is also 35. So by combining those 3 congruent angles, I get the total is 105, which is the measure of the angle BAE. Now, if I look at the 2 triangles here at the bottom of this figure, I know that I have an angle-side angle scenario, so DE must be congruent to its corresponding side, CD, so DE ends up being 8.